Okay, good evening. Welcome to
FamilyMath753a.
FamilyMath753. So I was looking at some videos of some lectures that were given at the joint math meetings, and there was this interesting one by Alyssa Kranz, and it was called Quintessential Quangle Queries. Quintessential Quangle Queries by Alyssa Kranz. And she defined this idea, I'll call it triangle B equals A, B, A inverse. And she gave, this was just one example in a 45-minute talk. And I thought it might be fun to talk about this because you've never seen anything like this, right?
Well, is this a to the minus 1?
Yeah. Have you seen something like that, a to the minus 1?
Yeah.
Okay. So, what would you think? Like, what would you pick A to be here if we're going to do an example?
Well, if this was a to the minus 1, then a could be anything except for really 0.
Okay. So give me an example.
So let's say it's 2.
2. And what do you want to pick B to be?
Maybe like 5.
5. Okay. So maybe she'd be talking about A triangle B 2 times 5 times what is 2 inverse?
That is 1/2.
1/2. Okay, and what does this equal?
So it equals 5.
Okay. What do you think would happen if I pick some other numbers?
Well,
It's gonna.
wouldn't it just equal B? Because A and the inverse A cancel out.
Oh yeah, how do you know that's true?
Well, because the inverse of a number is just 1 over it.
Uh-huh.
So you can, whatever these A and A, you can always cancel them because they're the same number.
They're the same number. And what's the rule you're using to cancel here?
Well, when you add the powers,
You'll get 0 as the power.
because a times a, it's a to the 1 times a to the minus 1.
Okay, so there's even something a little bit more subtle going on there. There's one other property of numbers you're using.
So the powers, when you multiply them together, it results in a to the 0, just 1.
Okay, but what are you multiplying together?
You're multiplying together 2 powers of a.
Okay, and why can you do that? They're not next to each other.
It's because multiplication is commutative.
Because you're using the commutative property. But interesting, so that property is so clear in numbers that you don't even really think about it when you're using it, right?
Mm-hmm.
Yeah.
But she gave a whole 45-minute lecture. This was just one example of these things she's calling a quangle. And I'm going to show you two examples where the order actually does matter, and we don't just simply necessarily return to where we started.
Okay.
Okay? All right, so let's take a look at the first one and let's see what happens.